2009 Physics Senior External Exam, Paper 1, Part B, Scientific Processes, Question 5. A group of engineering students sets up a simulator for a new roller coaster ride, a 12-kilogram trolley, so we have a mass of 12. Moves on a frictionless surface, so we don't need to consider the force of friction. PQRS below, the velocity at point P is 5 meters per second. What is the kinetic energy of the trolley at point R? For these particular circumstances, we need to know that the total energy is the sum of the gravitational potential energy plus the kinetic energy. Now it's going to be here that we set our height at 0, and so therefore our gravitational potential energy at R is going to be 0. So therefore our total energy here is our kinetic energy, EK. Here at point P, our total energy is the combination of our kinetic plus our gravitational potential. And here at point S, our total energy again is going to be the sum of our kinetic plus our gravitational potential. So we need to go through and work out these at point P, these at point R, and these at point S. Knowing, of course, that at point R, gravitational potential energy is 0, because that's where we set our 0 of height. So let's do the total at point P. It's going to be the gravitational potential energy, which is going to be m times g times h, 12 times 9.8 times 3. That's the gravitational potential energy at P, plus the kinetic energy at point P, which is a half mv squared. A half times a mass of 12 times velocity squared times 5 squared. So here we have our total energy at point P. So with our calculator, we can go through and we can do these particular calculations. 12 times 9.8 times 3 equals 352.8. 352.8. Let's work out the kinetic energy here at point P. 12 divided by 2 times 25 equals 150. Now we add that to 352.8 and we get a total of 502.8 joule. Now that's the total energy, and that total energy is going to be the same total energy here at P and at R and at S. It's just that total energy is made up of the combination of the kinetic and the gravitational potential energy at each particular point. So let's go to point R. The total energy at point R is going to be the same as the total energy at point P, but it's going to be equal to just kinetic energy, because the gravitational potential energy will be 0. So therefore 502.8 is a half times 12 times v squared. So v is going to be the square root of 502.8 divided by 6. So 502.8 divided by 6 equals, take the square root equals, the velocity is going to be 9.15. So the velocity at this particular point is 9.15. The kinetic energy of the trolley, of course, is 502.8. So 502.8 joule is the kinetic energy at that particular point. What is the speed of the trolley at point S? When we get up to point S, I'm going to need to slide my paper up. Of course, that particular calculation wasn't needed for this particular problem. But if we go here to point S, our total energy is our gravitational potential energy plus our kinetic energy at this particular point. Our total energy is 502.8. That's consistent throughout. M times G times H. And this is 12 times 9.8 times the height of 4 plus a half times 12 times V squared. So that's the kinetic energy at point S. So 12 times 9.8 times 4. Let's go. 12 times 9.8 times 4 equals 470.4. 470.4. 502.8 plus the kinetic energy. So the kinetic energy here is going to be 32.2. Kinetic energy 32.2 is going to be equal to a half times 12 times v squared. So v will be the square root of 32.2 divided by 6. Subtract 502.8 equals, just to connect that. I'll cancel that. So 32.2 divided by 6 takes the square root, equals, the velocity is going to be 2.31. So the velocity here, 2.316, 2.32 meters per second.